Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see a problem. Minimum increment for target multiples in an array. Now, it simply says that you are given two arrays, nums and target. As you can see, nums and target array are given to us. Now, in one operation, I can increment any element in nums by one. So the operation allowed is only and only increment operation, and that too just by one. Your task is to find out the minimum number of operations, or I should say rather, minimum number of increments required so that each element in target has at least one multiple in nums. What they mean is that, okay, if I increase 3 to 4, now 4 is divisible by 4. Then if I increase 8 to 10, then 10 is divisible by 10, 5 is also divisible by 10. So minimum increment required here in this case is 2, because only 8 needs to go to 10. What if I would have only increased 4 to 5? Then 5 is divisible by 5, but 10 is not divisible by 5. That is the reason, sorry, 10 does not divide 5. 10 does not divide 5. So basically target element should divide the nums, or I should say input element. So this is the primary use case. Now, again here 7 divides element, so no worries. So again, target element should divide the input element. Now, you have to choose correct element, right? You have to choose correct input element and then increase it by some value so that all of these should actually solve it. This is a kind of essence. But again, not one value, not important. So there could be possibility that, let's say I have any other value, let's say 6 or anything of that sort. So some target values can divide some nums of I, some other target value can divide some other nums of I. So ultimately, I can choose any number of elements from here, increase them such that all the elements technically should be able to divide something on the nums end. Okay, so far we got the essence of it. Essence is that imagine I have input nums as some elements and target as some elements. My primary task is that I will choose some elements out. Again, not necessarily I have to increase something, not necessary. I can maybe not required, but imagining T1, T2, T3, no one is able to divide anything on here on the left side, which means elements. So obviously I choose E2 and then I try to increase by some value so that T1 and T3 now start dividing E2, or I should say rather E2 dash, which is a new increased value. And same way my E4, let's say change to E4 dash, and then T2 now start dividing E4 dash. So your increment or your cost of new operations here required here in this case will be E2 dash minus E2, and it will be E4 dash minus E4. So this is your increment or cost required, and just you have to minimize this increase. So if you break it down, what you did, firstly you had the input array nums. You have to choose, which means this is not chosen, this is chosen, this is not chosen, this is chosen, this is not chosen. So imagining same way your crush has 4 options. She will choose, not choose. If you are here, not choose. If you are not here, she will choose. So this is exactly what DP also helps us to do. So if I have something as choose, not choose, I can simply, again, that's a very intuitive fact that I can try applying DP. DP simply says help us to take, not take. Now, whenever I am saying not take of what? Not take of nums. And when I say not take of nums, which means I will simply iterate with the help of index. I will simply iterate from left to right. And then if I am here, okay, good. If not, then go to next index. So if I am here, good. If not, go to next index. So simply go to next index when I will not take anything. If I will take it, then what? Then the actual fun part starts. Because if I take it, then obviously I will either, again, when I say take it, either it can directly divide, or I should say either it is one of the candidates that some element in target divides this thing in nums, or maybe in worst case you have to increase it by some value, so that you have to firstly increase it by some value so that the subset of target, again, that subset can be anything. that subset of target, again, some subset, any subset of target should end up dividing your input, which you have increased. Let's say E2, you have increased to E2 dash. So this subset of target should divide this E2 dash, which in the above case, if we remember, the E2 dash was 10, E2 was 8. So subset was value 10 and 5. So number 10 divides 10, number 5 divides 5. Okay. Now, firstly, you might say, Aryan, then I'm curious to know that are we trying to check for all these subsets? And that can be a first question which can come up. Again, not necessarily now, but maybe in the between. So obviously, you will try to choose all possible subsets. Now, subsets is a very big word because it goes exponential. But if we look at the constraints, we'll realize target length is 4, which means if I ask you number of subsets which I could have, ultimately, if I have 4 elements, every element has 2 options: take, not take, take, not take, take, not take, take, not take. So ultimately, I can have 2 raised to power 4 number of subsets for target. So, and again, this is pretty small. This is just 16. So I can have only 16 subsets. So I can try for all 16 subsets. Again, in worst case, I can try for all 16 subsets and check which one actually is dividing these, like this number E2. So obviously I will try for all possible subsets because of constraints. Now, the first question can be that, like if we will do and find all possible subsets, then I have to figure out or, compute or do something that all the subsets which I have, as in all the elements in that subset, and I'm actually taking them to divide with this E2 dash. So again, this thing is pretty crazy. Like, what to do now exactly? So it simply says that you will try for some subsets. Obviously, you have, let's say, first subset of target will be, let's say, empty, but that's not used. So one will be T1, other will be T2, other will be T3, other will be T1, T2, other will be T1, T3, other will be T2, T3, other will be T1, T2, T3. So I'm saying now T1, T2. Let's say this is one of the subsets. Now this one of the subsets should end up dividing again. When I say this thing individually, they should divide this E2 dash. So let's see how I will compute that. How much increase should be required? Because obviously to divide the E2 dash, you have to figure out what E2 dash actually is. To figure out that thing, I have E2. I have a subset which I can easily compute because the number are pretty small. So now my task is to figure out what E2 dash will be. Okay, let's see. So I have E2. I will increase it by some value to make it E2 dash. And I also have a specific subset with me. That specific subset, each element individually should divide E2 dash, which means that E2 dash by T1 should be possible. Again, completely divisible. E2 dash by T3 also should be possible. Now, what this simply means? This simply means that I have to find out E2 dash. Again, just forget right now about E2. Just imagine that you have T1, you have T3. You have to find some value E2 dash which divides which is divisible by both T1 and T3. So now what I will do, okay, I know that I have to find the minimum value which is divisible by both T1 and T3. What that is? By definition, that is nothing but LCM of T1 and T3. Now, if you don't know what LCM is, I highly recommend you can simply go and watch the math and number theory crash course. It will cover all of the maths concept, including, LCM, HCF, all things, factors, divisors, everything like that thing can cover. So you can just simply go to practice problems, right? Okay, link in description. Now, you know that you have to find the simple LCM now of T1 and T3. Now, when I say LCM, for the folks who don't know, LCM is nothing but LCM of two numbers multiplied by GCD of two numbers is nothing but the multiplication of these two numbers. So I have two numbers. I can easily compute the GCD. If you don't know, we have an inbuilt function also, underscore GCD, or else for the folks of Java, we have a very standard approach of how to find a GCD. With this formula, I can compute the LCM of two numbers. Now, with this formula, I will be easily able to figure out, okay, what should be the minimum value, or I should say, what should be the value which should be there. Let's say this E2 dash can be at least more than LCM of T1 and T3. Now, again, the question comes up. Now, okay, we have found out the LCM of T1, T3, but still, E2 dash is still not known because even if we find out the LCM of T1, T3, let's say the LCM is 6. Let's say T1 would have been 2, T3 would have been 3. LCM is 6. But what if my this E2 again, because E2 dash is unknown, but what if my E2 would have been number 10? Then what? Obviously, you have to make another number E2 dash such that my LCM, because obviously we realize that this is a minimum value which is 6. Now I have to somehow increase this 10 to a value such that it is divisible by the LCM. So in theory, I can increase it to 12 because now 6 is divisible by 12. Why this was possible? This was possible because 2 is also not divisible by 12 and 3 is also divisible by 12. So did you see what I did? Firstly, I found out the LCM of T1 and T3. That gave me the minimum value. So no matter what, E2 dash should be higher than or equal to 6. But then I also realized that my input value which I have in hand is 10. Now this 10 I have to increase it to some value. But after I increase it, it should always be divisible by 6. Which means if the number is 12, the next number which I could have tried off would have been 18. But obviously I will not try the next number because I know I want minimum increase, because my question simply mentioned or asked me to have minimum number of operations. So I went on back and this is my thing. Okay, how I will compute it or increase it. So here I mentioned this that E2 dash is unknown, and how I am computing it? I am computing by simply saying take the E2 divided by the LCM. Whatever you get, make sure to get the seal, right, of the seal value. Again, I will tell you the example also what that is. Multiply back with the LCM, then you will get the actual E2 dash. This is exactly same as what I discussed above also, but I will tell you once again. Imagine E2 dash, sorry, E2 is your 13. Again, LCM of two numbers is 6, right? Roughly same example. Then I have to find E2 dash. E2 dash is just, again, E2 dash is just higher number than 13, which is divisible by 6. So obviously, if I check what is, again, if I ask you what is the just lower number than 13, which is divisible by 6, you will simply say, Aryan, I will find the question which is 2. The question says, okay, 2 is the just lower number. So 2 into 6 is nothing but the base itself. It is 12. So it is the just lower number, again, which is divisible by 6. Yes, which is divisible by 6. Yes. And now again, like why I'm speaking it cautiously, because I mix match like divisible and divides things. So I have to make sure that okay, this is properly accurate, like whenever I say divisible versus divides. So now your task is okay, just to get a higher number, because the only operation required or allowed here is increase. So now if I have 13, I will take a seal that will say 3. So 3 is the corresponding quotient. So 6 into 3 will give me 18, and 18 is a just higher number than 13, which is, again, when I say just higher, I mean just higher or equal number than 18, which is divisible by 6. Cool, because obviously you multiply by 6, that's the reason it will be divisible by 6 itself. So that's how you can get your 18. And ultimately, when you know E2 dash, you know that E2 is your current number, E2 dash is your new number. Subtraction of E2 dash minus E2 will give you the operations required to solve this problem. Now, finally, if I do a quick summary, you will take something, you will skip something. What? From what? From nums. If you will skip it, you will obviously go to next index. Again, it's a simple DP. Again, if you don't know what a DP is and how to solve it, simply come down and reach to okay, this will be with my patient again. I'll just talk about it also. But if you want understand DP, just simply come down and solve the DP problems. As simple as that. Just practice. Cool. Now coming on back, if we will take it, we know that we have to get the additional cost. because obviously if we have some number we are taking it, which means that if it is e2, I'll have to increase it to some other value which is e2 dash, and that increase will be nothing but a delta. Again, that delta can be 0 also, but again in general there will be some increase which I have to put up, and then go to next element. But the catch here is that how will, again, obviously, let's say if you take this element and that element actually handles, again, if you remember, if I go back to the beginning, my target had three numbers, t1, t2 and t3. And in my nums, I had e1, e2, e3, e4, e5 and so on and so forth. So what I did not take E1, I took E2. But that E2 when I took up, it actually already handled T1 and T3. So right now, going ahead, I only and only need to handle T2. Right? That is the reason I somehow have to apply some operation such that I can monitor which elements I have taken in my target and which not. So that is my task. That just monitor that which subset of target you have already taken or not. Now, to handle these subsets and to know that what is taken, what not, what is available, what not, we simply use a strategy of mask. If you don't know what mask is, I'll highly recommend go and watch the bit manipulation crash course. And again, if you want to practice it, again, as I mentioned, simply go and watch the bit manipulation practice problems from easy to hard. You will get everything. Coming on back, we simply realize, okay, we have to do the masking just to figure out what subset is already taken. Now, if I give you an example, if let's say this would have been a mask, so 0, 0, 0 would have been, okay, nothing is visited so far. So the E2 will try for all the possibilities. E2 will try for all the possibilities, which means E2 will try taking, okay, 1, 0, 1, right, and 0, 0, 1, and then 0, 1, 1, then 1, 1, 0, and then 1, 1, 1. So E2 will try. E2, when it is about to take, as I told, it will try for all possible subsets, right? And then for each individual subset, let's say in this case, it took T1, T3. So let's say, okay, one more example, 1, 0, 1. So it took T1, T3. Now T1, T3 is gone. So the next time, the mask which I will forward to the next number, that mask will make sure that I have put up like this. 0 indicates it is not yet taken and my task is to take it. And ultimately, mask of 111 indicates that everything is taken now and you are good to go. Now again, masking and everything is actually a very good concept and it is mixture of maths. Again, it is a mixture of, as you can see, LCM, HCF, DP, masking. So again, if you don't know any of this, I'll highly recommend come to this specific practice problems list. Again, it is structured, ordered, everything. Come here, individual practice it. If you are good with individual concepts, then come back to this video. Cool. So now I realize I'll simply use a mask to handle the corresponding subsets which I have taken. How will it go? Simple. The mask, as I mentioned, that it should update. So if I have taken this specific subset, my existing mask was this, as I mentioned. Let's say my existing mask was 0, 0, 0. I took the current subset of 1, 0, 1. If I do an OR operation, I will get a new mask saying 1, 0, 1. So this is my new mask. Next time when I will try to iterate, I will check what all locations are not yet visited and only those one I will simply check. And again, as I mentioned, the subset which I can try off is from 0, 0, 0, 1 to 1, 1, 1, 1, which is nothing but from 1 to 2 reach for target minus 1. Again, all these concepts are covered in bit manipulation crash course, which you can look at it. Cool. Now we have everything. So if I just give a very quick recap, what we did, firstly figured out that it is a take not take. When we saw it's a take not take, then we realized, okay, if we not take, then simply move on. If we take it, then simply increase. If we increase it, then choose what from target. Obviously try for all the possibilities of a subset from target. When I choose it, I know, okay, I have taken one specific target, one specific subset of target, but obviously I have to figure out how much increase will be possible. Then I found out the increase, whatever will be there. If that increase is there, now I know the difference which I have to add in my answer and then go on to the next index to solve it. And again, to handle these subsets, we realized that we have to make sure that we are visiting and not revisiting the specific index which is already visited. That's the reason we have to take a mask. That mask will actually help us to figure out what we have done and what not. Cool. Let's see the code. It's exactly very same as what we have discussed. Now, if you realized, I have taken some of the global variables, nums, target. Why I have taken it is because I don't want to pass it again and again in a function. Then num total is nothing but your n, and it is nothing but your m. Cool. Then I have initialized my DP, with the default value of -1. And I have also initialized LCM pre-computed. If you remembered, I have to compute LCM. Now, LCM of what? LCM of T1, T3. What is this? This T1, T3 indicates one of the subset. Obviously, this indicates 101 as one of the subset. Again, this 101 is a mask and it represents a subset which I have chosen to compute the LCM for. So what I did, I just pre-computed the LCM for all possible subsets. I know I have 16. I have 16 subsets. So I'll compute the LCM for all of these subsets. Now, when this is computed, I know that I will be good to so use it. And how I can use it? I can simply call the value of 5. That 5 LCM pre-computed of 5 will tell me 5 will say it is a 101 value. This indicates for T1, T3, what is my corresponding LCM, right? Okay, let's firstly go on to pre-compute function of LCM. So what this will do, pre-compute LCM, this will simply go and try for all the subsets. Again, this is a standard technique to go and try from value 1 up till 1, 1, 1, 1, right? 1, 1, 1, 1. It is 0, 0, 0, 1. Cool. Now, when I go for every subset, okay, for the current value of that specific LCM, I put up default value of 1 because I know I have to next compute the LCM. Again, why I have put up default value? Because simple LCM of 1 and that number, let's say A, will be nothing but A itself. So I just give a default value 1. Then I went ahead and tried to go to the entire array of target which I have with me. And then if I figure out that let's say the current subset says 1, 0, 1, 1, right? It will say, okay, the first element is there, second is there, third is not there, fourth is there. So index 0, which is the first element or the zeroth element, if I again one left shift J will make another mask. Again, all these concepts are covered in bit migration crash course, so I'll highly recommend go and watch it. But what this will say, okay, 1 left shift 0 times, if the resultant AND value is not 0, which means this location, this jth location inside my subset was set, so I have to include it in my corresponding LCM computation. So LCM computation for that specific subset which is being computed, which is this in this case, says that please incorporate the jth index target value. Jth index target value, I've incorporated it. And again, it is simply nothing but computing LCM. As I mentioned earlier also, LCM of A and B will be nothing but A into B divided by GCD of A and B. But let's say if I want to find the LCM of A into B into C, then firstly I'll find the LCM of A into B. Then when it is done, so LCM of A and B is done. Now this is my new equation. What is this? This is nothing but A, which means this is nothing but LCM of A into B, right? Sorry, A comma B, and then into C divided by GCD of this value, which is LCM of A comma B, and then C. So what it did? Ultimately, you are finding the LCM of two numbers. One number is this, another number is this. So whenever you want to find the LCM of two numbers, A and B, you simply ask your LCM. Now that compute LCM will be simply nothing but A into B divided by GCD of two numbers. So what this will do, this knows that you have to compute the LCM of two numbers. First is this, second is this. This ultimately indicates that first is already a subset, second is a target value. So this is exactly what is happening here. And again, you can apply the same formula: subset, target value, subset, target value. Cool. Let's again, it's a bit hodgepodge, but yeah, it's completely clear, I guess. Now, next is when the LCM is computed, now simply go and solve starting from this index with the current mask. Mask indicates what all target elements I have taken so far. and index indicates what is the current element in my nums. So this indicates current element in my nums. This indicates what I have taken in my target so far. Then if the mask reaches 1 1 1 1 1 1 1 1, which means okay, I am good to go, which means I can simply return 0, which means my corresponding all target elements are taken, because mask was 0 in the beginning, mask was 0 in the beginning, and if it is in the last 1 1 1 1 1, which means all elements are taken. If the mask is 1 1 1, all elements are taken. Okay, let's proceed forward. If it is not, which means if mask is not 1 1 1 1, but I have reached the end, then I should return infinity. Why? Because it indicates that now I have reached the end. I have not taken all the target elements, which means there is still some target element missing, which is not considered in my current answer. So simply return infinity. Why I returned infinity here and why 0 here? Because I want to minimize the number of operations. To minimize it, if the things are good, give the minimum value. If things are not good, give the maximum value. Cool. Again, all these are the basics of DP, which is already covered in the practice problem. Now, the simple DP check, if things is not -1, then simply return the corresponding DP value. Now comes the fun part. First part is not take. If I don't take it, which means simply call I plus 1 with the current mask. That's it. Simple. As simple as that. But this is for not take. Not take. But if I take it, and when I said, if I take it, which means the ith index element in nums, I am taking it. I will go on to all possible subsets in my target, right? I'll go to all possible subsets in my target, and then I will compute the LCM of that specific subset. Again, take the same example, T1, T3. So I went ahead to all these subsets. One such subset is T1, T3. I computed the LCM, and again, I have already pre-computed it. So simply take it from the pre-computation. Then I will check what is the next multiple of that subset, which is also higher than nums of I. Exactly same formula. Seal division by the LCM multiplied with the actual LCM value. Cool. Then when this is done, you can simply proceed forward with minimizing the answer with, obviously, this is the E2 dash, right? This is the E2 dash. This is the E2 existing value, and then go next index, but with the current mask, so with the new mask. Now, you might have a very basic doubt that Aryan, why haven't you had a check where you are excluding any of the things which are repeating? What I mean by that is, many people can have a doubt that Aryan, let's say if the mask here is 101, right? But 0101 like this. Now it says T1 and T3 are there, and I have considered them, and obviously this mask will ultimately say I have considered them, and when this will go at the very top, it will indicate the mask is being considered. So technically I should look only and only for the subset values which are having this location set or this location set, which means it can be either 1 0, like again ignore these ones, or it can be 0 1, ignore these ones, or it can be 1 1. So I should technically include only these subsets. That is a good question, and obviously that we can add it as a if condition here, but it is not that much required, because obviously you are always adding positive stuff. So even if you add more, you might actually exceed that value, and minimizing it will still give you minimum value. Again, it is good for pruning it, but not that much significant. Cool. Ultimately, after you take it, you will make sure that you are memoizing your DP value. Now, obviously, because of going on to all the indexes, which means of the input, and also the mask, which is 2 to the power 4, this itself will take n into 2 to the power 4 as a time, along with going on to all the subsets, which again take 2 to the power 4. Thus, the time complexity will be n into 2 to the power 4 multiplied by 2 to the power 4. And then ultimately, a space will be n into 2 to the power 4 because of the DP. Cool. I hope you guys got it. Again, it's a mixture of 4 concepts, which is pretty great. Bye bye. Take care. Make sure you check out this, and again, crash course link in description. Bye bye.